So we're gonna start off today's exercise with a problem that has 1a. We've got y equals 3/4 of x squared, and we must find inverse of the function. So we start off with f of x again. It's 3/4 x squared, and then the rule to get the inverse, we substitute x and y, yeah. So one swap x and y such that x equals 3/4x squared. Oh, my bad. Oh, this eraser looks so cool.
What does it look like?
So I'm gonna doodle there, and then when you erase, the stuff
It
falls off.
gives you that thing, like it's just like an
Eraser, yeah. And then we make y the subject of the formula, right?
Yes.
To make y subject, so 4/3x equals y squared, then y equals, do that, it's obviously square root of x, and then there's also 2/square root of 3. Okay. And this is f inverse of x, positive, negative. All right. What else do we have to do? We can, let me add a new page, new jam. Yeah. That's not what I wanted to do. I wanted to refer to here. Oh, okay, so we've made the other one subject of formula. What's the third step again? Oh, we must draw. Draw the graph.
Was it really draw?
Yeah, we can draw the graphs. So we'll just, I wanted to recall the formula. Yes, it's that, okay. So it's f inverse of x
2/3.
times that, ne?
Yeah.
We
It's
can,
2.
oh,
You wrote
you mean
2.
like this?
No, I'm talking about the
what?
the numerator. You said it's 2. You wrote 2 there.
Yeah.
Yeah.
Because it was 4
Yeah.
over 3, and this equals 2/3, like that. Okay. I think we should set up a table. F of x was how much? Was
f of x was
3/4x squared. Okay. And then inverse x. Okay. -2, or maybe -2.
No, it just says determine the inverse function of the following. functions, so we just have to find the inverse.
Inverse. Oh, we don't have to.
We don't have to sketch. They're not saying is this
The
a
thing, yeah.
function or not. If we have to find the function, that's when we're gonna have to draw to see the
Okay.
shape and the type of
Okay.
function it is.
I like that insight because then it shows you're paying attention to the problem, or at least what it's asking. At least what it's asking. So from f of x equals 3 over 4x squared, then our inverse becomes f inverse of x is positive or negative 2 over the square root of 3 times the square root of x. For b, we've got 4y minus 8x squared equals 0. We can make y the subject of the formula. So we have 4y equals 8x squared, and y is 2x squared. Now to find the inverse, we swap.
X and Y.
So we swap x and y such that x is 2y squared, and then we make y subject of formula. That becomes y squared equals x over 2, and y is the square root, positive or negative
X over 2.
square root of x over 2. Okay. Then let me add another page. Page 3. Okay, we've got x squared plus 5y equals 0. This is number C.
X squared is equals to minus 5y.
Or 5y is negative x squared, and y is negative x squared over 5. That's our f of x. Then to get f inverse of x, we will have first swap the y and x values. So x equals negative y squared over 5. Then we make subject of formula such
This is
that
equals to 5x. Yeah, 5x, yeah.
5x is y squared, no? Then divide by negative sign so that negative 5x is y squared, and then take the square root such that squared equals negative 5x. Okay. Y would be positive or negative. This is something else. But that means x must be less than 0. Because if x is positive, we're going to have a negative number, and the negative on the square root is not
It's
exactly
an error.
Yeah. Should probably check out the other ones. What are the conditions? Okay, that means here x is positive, and that means here
X is positive as well.
x is also positive. Yeah, so we should always have those terms,
And
conditions stipulated. And then the fourth problem, number D, we've got 4y minus 9 equals x plus 3 times x minus 3. This here is x squared minus 9, and that equals 4y minus 9. That means 4y equals x squared, because if we add
cancel out each other.
They
Gives you 0.
additive inverses, yes. Then y is x squared over 4. Now to find inverse of f, we swap x and y.
I'm gonna have x y squared over 4.
Correct. And then what do we do next?
We make y the subject of the formula. I'm gonna have 4x.
So 4x is
equals
y
to y
squared.
And then you're gonna root it.
Yes. Then we square root. So that gives us positive or negative
4x. Root of 4x.
2 root x.
Okay.
And again, x is also positive. Alright. Let's do this function number 2. Oh, this is still exercise, eh? 2, 4. And this is on page 66. Okay. So yeah.
So you see an I looks like an A.
Yeah, that it does. Does it look better now?
Yeah, kind
Okay.
of.
Alright, so we've got a function. It's g of x.
1 over 2.
It's a half x squared. And we're only considering the part that's positive. Alright. So we must find the inverse of g. So find g inverse of x is the first step. Step 1 is to swap y and x. So x equals 1 over 2 y squared. Make y subject of formula. That means 2x is y squared and y is positive or negative root 2x. Alright. And then that's g inverse of x. Okay. And I guess here also x must
Be greater than 0.
must be positive. The second thing we must do is plot g and g inverse on the same set of axes. So let's make a table. X, g of x, and
G inverse.
g inverse. Absolutely. G inverse of x. That means if we start off at -2, -1, 0, 1, and end at 2, and we plot graph for these two. For g of x, what's g of x at x is -2? It's 2. That means this is 1, 0, 1, 2. It's not.
It's half.
Oh yes.
Because 1 becomes positive, and then 1 multiplied by half gives you half.
Gives you half. That's an excellent observation. Thanks.
That gets that one. Yes.
Okay. And then for g inverse, what's g inverse of -2? That's mine here.
Error.
It's an error, ne?
So it goes from 1 1 as well because it gives you negative
Okay.
in total.
So that means the parts that are negative, where x is negative, we don't consider. Let's look at it for where x is 0.
0 is 0.
Okay, and where x is 1.
Root of 2.
Positive 2.
Yeah.
Plus 2. And where x is 2.
2.
2. Wait. What?
Positive root of 2.
The first one is
For
positive
1.
root of 2.
Yes.
Okay. Okay, and then let's check for, so we're doing for the positive part. That gives us, so this here gives us for, we're just imagining it here, right? This here gives us, for x is positive 1, that's somewhere just above 1. So it gives us somewhere there, and then for x is 2, it'll give us somewhere there, right? So it'll look something like that. What about this part here, where,
The inverse.
yeah, which is for the, this is for g of x is plus root 2x. We need for g of x of negative root 2x. We need for these values as well. Do you follow?
No.
Remember, the inverse is not a function if it fails the vertical line test.
Okay.
But if we kind of,
Manipulate it.
I guess you could call it that, and we just look at this part here, then we're considering that, and that is a function. So for this one, we've got these values here.
Okay.
So we must do the same process.
Oh, okay.
You follow?
Yeah, because we have two values of root of 2x,
Yes.
the negative and the
And the
positive.
positive.
Okay.
So we must do for the negative as well. So it's gonna be 0. I think most likely negative root 2.
Even the negatives still not working, so 0 is 0, 1 is negative root of 2,
Okay. And the other one is
negative 2.
negative 2. Okay, cool. So we must plot g and g of x on the same set of x's. Okay. I'm just gonna erase this because it's making the sketch look messy. Can you help me with something? I want us to write this table but transcribe it onto your notebook because my space here is not gonna show everything.
And my book.
So we're just going to copy those. So we've got g of x is a half x squared. G inverse of x is positive negative square root of 2x. That's correct, right?
Yes.
Okay. And then we have a table g of x, and g inverse of x is positive root 2x, as well as g inverse is negative root 2x. Alright. So we said negative 2 So here we had what?
Positive
Positive
root
square root of
2.
2, and here we had negative
Negative.
square root of 2.
Mm.
Here we had just
Positive 2.
2 positive and
And then
just
negative
negative 2. Alright. So now, just so we can see what's going on, red will be our initial graph.
Okay.
Blue will be positive 2x of the inverse, and green will be negative root of 2x. Alright, then we are plotting. As we are plotting, we'll have a negative 1 there and a negative 2. And this is on the x-axis. And on the y-axis, we'll have 1, 2. We'll also have negative 1 there and a negative 2 there. Somewhere there we'll have 0, then we'll have 1 and 2. So our red graph, what are our points again? For x is
2.
negative 2.
Negative 2 is equals to 2.
Maps to 2. And that point is negative 2, 2. And then for negative 1,
Half.
we map to half. So somewhere in the middle there's a half. So we'll have negative 1, a half. And then 0, 0. I'll just leave it at that for now. We'll fill it in when we're done. Then the thing mirrors. And then our cap looks something like that.
Ish.
And that is...
That was the most neatest graph you've made.
Thank you. G of x is a half x squared. Then we do blue graph. Blue graph at 0, we have 0. At 1,
Negative.
we've got, so it's just over 1 point.
It's 1.4.
For something, so 1.5 should be there, maybe a little bit below, so it'd be there somewhere. And then at 2, so that's 1 is 2 root 2, and then at 2 it also maps to 2, right? So our curve will, yeah, just something like that. And then for the green, oh, let me first finish off there. That's 2, 2. And for the green, it's pretty much the inverse of the other one. So we'll map 1 point there and another point there. And that curve will curve like that. Also another neat curve.
Yeah. I think you're getting better and better at the goals.
Thank you. 2x like that. I should put the name of the graph there. Equals positive root 2x. Alright. So now we must answer real tough questions. They want answers here. So we've drawn G and G inverse on the same set of x's, right? Is G of x a function? So in other words,
No.
is this a function?
No.
Why?
Because the vertical line cuts it twice.
So to answer part C, this is part B, right? G of x is not a function
It does
because
not pass the vertical line test.
it fails vertical line test.
Such a simple test.
Do you know other tests that other people have failed before?
Hmm?
Do you know other tests that people have failed before?
Yeah.
So there was the black hair test when, so you know South Africa's colonial history, right? And obviously we had other groups forming that were mixed race, right?
Okay.
And as those were forming, other people then decided, even if I'm dark skinned, I'm just gonna adopt someone's surname and then claim that I'm also mixed race.
Oh.
Yeah.
Okay.
And then to dispel that, authorities were like, no, stick a pen through their head. If it doesn't get out,
I was gonna fail the test with flying colors. I was gonna fail with flying colors and I was gonna be crying because I wouldn't get the pen out of my head. It would just be stuck.
so I mean, it's a very sensitive part of our history as South Africans. But the fact that it's such a simple test, and people are like, I gotta survive.
That's why they had relaxers. That's why.
That's probably why relaxers became popular.
Relaxing with pig's oil.
A lot of. Actually, there's a science to that whole thing, but we'll do that in science class. But just to give you an idea, there's a chemical, it's a strong base called sodium hydroxide.
Okay.
When mixed with some kinds of fat, it actually unblocks drains because of that. Yeah, it sort of melts down fats, right?
Mm.
So they use it as a drain unblocker, sodium hydroxide.
A drain and blocker.
Yeah,
You
but
said blame.
I said blame. Sorry, a drain unblocker.
Okay.
But in cosmetics, the same active ingredient has been used in cream relaxer before by big brands before. So
Yeah.
yeah. But anyway, that's for science class when we do chemistry.
I once had next hair before.
Is that?
When I was like in grade 4, 5, and 6.
Okay.
Then I cut it off.
We were inspired by Little Bow Wow when he used to have cornrows. So he'd straighten the hair on Friday and plait it, and then Monday comes, you have to unplait your hair.
Because you're at school.
Because you're at school. And then growth. And then you're like, nah, this trend is whack. But yeah. So let's do domain and range, right? So for g of x, what's the domain?
Domain is what? X
Values,
X
yeah.
values, right? So X is an element of real numbers. Where
Alright.
X is both positive and negative.
Yes. So it's a set of x values such that x is a real number.
Mm-hmm.
Let me just say x is a real number. And what's the range?
Y is greater than 0.
Equals or greater than 0,
yeah.
correct.
Y
And
is an
it's
element.
also a real number.
Mm.
And then for g
Inverse.
of x, g inverse of x equals positive root 2x. What's the domain?
X is greater than or equal to 0.
X is definitely greater than or equal to 0.
And X is a real element of real numbers.
And it's a real number.
Yeah.
And the range?
Range. Y is greater than 0.
Y is also
So greater or equal to 0.
0.
Y is an element of real numbers.
And it's a real number. Y is an element of the real number system. Okay,
Mhm.
and then the last part, g inverse of x equals negative domain?
X is x is less than 0, less than or equal to 0.
Wait, what?
X is less than or equal to 0.
No, but that's
positive that's for
x.
y.
Yeah, that's
X.
for y.
y is equal to.
We're still doing the domain.
Yes. I mean, x is greater than or equal to 0, and x is an element of real numbers. And then for the range, we have y is less than or equal to 0.
Correct.
And then y is an element of real numbers.
Excellent.
Yay.
Determine the last part. So we must determine the coordinates of the points of intersection of the function and its inverse. So E, ne? Points of intersection G of x and G inverse of x, right? So let's look back at our graph. Where do the graphs intersect? Where do they?
0 is to 0.
At 0, 0. So right there. And
then
where
at
else?
2 is 2.
At 2
2.
is 2. And this is only for G of x and G of x for the positive Ntulanene. Oh, by the way, that actually does go with that theory that
y is equals to x.
Is their reflection axis, yeah. All right, so we know from the graph G of x is a half x squared and G inverse of x is positive square root of 2x intersect at the point 0, 0 and 2, 2. And those are the correct answers. The other one doesn't have a point of intersection per se, but we can just note it for reference. And
0 to 0 looks like eyes and a nose.
It looks like eyes.
And like I have like a mole here by the eye.
Oh yes, I see. You're quite imaginative. Half x squared and G negative 2x intersect only
0 is to 0.
at 0, 0. All right. Okay, this problem looks nice. Problem 3, ne?
Yeah.
We're given f of x is a x squared and x is positive or equal to or greater than 0. And we're also given a point P for Mr. P is 1, 3, right? And we're told that it's a parabola. And how the graph looks, it looks something like there's the y-axis, there's the x-axis. Right, so at 0, 0, the curve starts. And for 1, 2, 3, I'll just put 4 there because there's space. -1, -2, -3, -4, there's space, I guess. So I'll just put there -5. And then we'll have it's there somewhere. -1, and then there's 1 right there. So we're told that our curve has got the points 1, -3, and 0, 0. and it curves something like that. That's our graph. F of x is ax squared. Alright. Now we must determine the equation of the parabola. Okay, how do you think we'll do that?
We have to find the value of a.
We have to find the value of a.
Yeah.
That's a good observation. So how can we do that?
We substitute the points of p into the equation that is given in order to find the value of a.
Okay. So p is
1 is to negative 3.
okay, and those are xy coordinates, right?
Yes.
1, negative 3, that's x and y. So we can start by substituting point P, 1, negative 3, into y is ax squared, and we will have negative 3 equals a into 1 squared. Therefore, a is negative 3. This means f of x is negative 3x squared. Okay, so we've pretty much done part A. Part B, we must state the domain and range of f. Right, so f of x is negative 3x squared. Remember, we're only given this half of the parabola, so we must state the domain of this part and the range of that part. So starting with the domain, what's the domain?
X is greater than or equal to 0.
X is definitely greater than or equal to 0.
And x is an element of real numbers.
And it's a real number. And what about the range?
Y is less than 0, less than or equal to 0.
Less than or equal to 0.
And y is an element of real numbers.
And also a real number. Okay, so we're done with B. Then part C. So we must give the coordinates of the point on F inverse that is symmetrical to the point P about the line y equals x. Okay. So the line y equals x would be something like that, right?
Yeah.
That's y equals x. And we must give the coordinates of a point on the inverse function. How do you think we can tackle this problem?
We must find the inverse function first.
We must find the inverse function first. Okay. So we have our function y equals negative 3x squared. So to find the inverse, we must first substitute or swap rather y and x such that
X is equals to
x is negative 3y squared. Perfect. And then we make y a subject of formula. Make y a subject. Then that is
y is equals to and then you root it.
And then we take the square root, right? I'm just trying to think, how do we do that here? Y would be positive or negative.
Yeah, and then x should be less than 0.
X should definitely be negative. Yeah. So that means Oh, this is actually quite cool. Because now we know that in order for the inverse to be a function, it must be somewhere on this side.
Yes.
Where x is negative. Because any values of x that are positive give us something that's not a function, that we can't make sense of, yeah. Alright. So now we found that f inverse of x is positive or negative that, right? This is how manipulation works, eh? Alright, so do you think it would help if we drew the curve?
Yes, because we'll be able to find the coordinates and visualize what we're working with.
Okay, let's draw the curve. Not try, let's rather do it. It's not a straight line. It's a curved line. It's a better straight line.
That has curves.
Mm-hmm.
It's a straight line that has curves.
It has curves. 1, 2, 3. -1, -2, -3. And we've got that point there is P. We've got -1, -2, -3, and we've got 1, 2, and 3 up there on our y-axis, and this here is our x-axis. Just gonna do I'm just gonna draw the line. Oh no, it's not exactly straight, and it doesn't pass through 0, 0, so I'm gonna redo it. Okay, there's y equals x. Right, our f of x would be the one in blue. So f of x is -3x squared. And our green would be our inverse function. Yeah? Okay, so we are going to focus on values of, for f inverse, we're going to focus on values of x that are less than or equal to 0. And we're going to draw that graph in green. Let's make a table.
Sure.
Okay, so we'll start at maybe -3. -3, -2, -1. Okay. At x is -3, what's the value of?
It's 1.
It's 1, eh? So f is -3, that is 1. At f is -2,
Root 6 over 3.
root 6 over 3. In decimals, what does that give us?
0.82.
0.82. So just, that's at x is -2.
Yes.
Okay. And then at x is -1?
I think that's root 3 over 3.
Okay, so at
It's
negative.
0.58.
Oh, okay. So the curve's gonna look something like. Not looking curve. Okay. So that's.
And then for the
like that?
Yeah.
Oh, okay. Okay, but it's fine since we don't really. Oh, okay. So it's gonna be 1, sorry, 0.5 something, ne? Which is somewhere
0.58.
there. And the other one 0.8 something, which is somewhere there, and the other one would be there. So curve would look something like that. Maybe like this, and then I need to redraw this. Let me just erase that. Okay, since I've erased that and that, this would be that looks better. Okay, so I think I should have made this one red. Yeah, let me make it red. I'll make it red. I'll make it red. I'll make it red on this graph. I'll make it red. Well, that's a nice remix.
So I think you're like a 10-year-old stuck
In a 30-something-year-old's body.
Yeah.
That's fine. I mean, that's how genius is formed. I'm not saying I'm a genius, but I'm saying that's how genius is formed. Anyway, I'm gonna do the red f of x. F inverse of x is negative root negative x over 3, and then the green would be f inverse of x is positive root of negative 3 over x, and then the blue, we've got that sharp. So now we are to answer the question, right? We are looking for coordinates symmetrical to the point P about the line yx. Let's have a discussion first. So on the green graph, which is f inverse, but for the positive root negative x over 3, we've got the point 1, no, it's, what is it, negative 3 is to 1, and on the red curve we've got the point negative 3 is to negative 1. Right. Now, if we're going to talk symmetry, we must talk about, remember, like our two hands looking like that, so they must map onto each other. So between the point negative 3 and negative 1, as well as the point negative 3 is to 1, which one looks like it does that thing of our hands mapping?
Negative 3 is to 1.
Negative 3 is to 1. So the one for the positive graph, the green graph. Okay. So it looks like, we'll call it P with a little thing there. The little hat. So it looks like the inverse of P is P with a little thing there, and P with a little thing there is negative 3, 1. And that answers the question. Okay. That's for C. And then for D, we have to determine the equation of F inverse, but it looks like we've done that. So we'll just write f inverse, the one that's actually a function, would be positive, or rather.
You know what we could have done?
What?
We could have just swapped x and y to get the inverse on p. To get p inverse, we could have swapped the values of x and y.
Oh, that actually also does make sense. Because then we wouldn't have to answer the question that comes before answering the other question.
You understand?
Okay, we could have done that. But we've done it.
It's cool. It's alright.
Yeah.
Because it's not that I think of it, because when we're finding the inverse equation, we have to swap x and y.
Okay.
And here, to get the inverse, you swap x and y. Understand? The value of the inverse function is -3 is to -1, which is the swap
X and
y of the original.
You're actually correct. You must keep making those observations, because they'll save you a lot of time in the exam.
Yeah.
They'll save you a lot of time in the exam. Definitely. Or in a test. So let's do number E and work out domain and range. So for f inverse of x, the domain is what?
F inverse. For which one? Positive or negative?
I guess we can do for both, but let's start with the positive.
For the positive, x is less than or equal to 0. And x is an element of real numbers. It's for the positive, right?
Yeah, for the positive.
And then
X is...
I mentioned for the positive.
Yeah, you said X is?
X is an element of real numbers, and x is less than or equal to 0.
Awesome. And the range?
Y is an element of real numbers, and then y is greater than or equal to 0.
Okay, and a real number.
Yeah.
And then for the negative one?
For the negative, we have x is an element of real numbers, and x is less than or equal to 0.
X is less than or equal to 0, and a real number.
Yep.
And the range?
Y is less than or equal to 0, and then y is an element of real numbers.
Alright. Then this one will be for that. The other one will be for that. Okay. And it looks like we've drawn the graph of f inverse already. So we are sharp.
Yes.
We are sharp.
But I think this is also important to do things ahead, analyze what you have and what you don't have using the graph. That way it's easier for you to answer questions.
That's also true, because we are kind of just reading off all the answers for E and F, or rather E and D, because we answered the question of drawing the graph first. That also works. Unless the marker is very strict, but I don't think they would be like that. Like, why would you be that strict? Like, why would you be that hectic to say you didn't answer in sequence, therefore you fail? I'm not sure if they can do that.
So I think you can just write them down according to their numbers.
Yeah.
Because I think I don't mind you writing however you want, as long as you number them according to the question paper, so that they can mark accordingly.
Yes, that is true. Let me move a little bit closer. Okay. New page. Number 10.
What are you page 10.
Yeah. But the nice thing is that not only do we have a video recording of the screen, everyone who's not able to attend class will get the notes live, so to speak. So as soon as they go on the email, then the class notes will be there.
Oh, that's cool.
Yeah.
4.
Number 4, ne? Okay. Number 4. Put a circle around it. Okay. So we must find
the inverse of h of x is equals to 11 over 5 x squared.
h of x is 11 over 5 x squared. If y is 11 over 5x squared, we swap x and y. So x is 11 over 5y squared. Then 5x over 11 is y squared. Therefore y is I'm just pointing out that in this step we multiplied by 11 over 5 on both sides, and in this step we took the square, so that becomes, and x must be positive. Yeah. Okay, so we've determined the inverse. B is to sketch both graphs. B, okay, sketch so h of x is 11 over 5x squared, and h inverse of x is 5x over 11 square root of that, positive, negative. Yeah, like that. Okay, maybe let me make this look neater. Yeah, like that. Thank you. Then we're gonna do points. Let's have x, h of x, h inverse of x equals positive 5x over 11, and h inverse of x equals negative 5x over 11. We can start for values of -2, -1, 0, 1, and 2. Yeah.
For -2, 8,8.
That's for h of x.
Yeah, h of x.
8.8.
Yeah.
8.8. For -1.
2,2.
2.2. Awesome. 0, 0.
Yeah.
So that means it's also 2.2 there again. And 8.8. Do I have enough space? We'll see. Then for the inverse, the positive side,
-2, error. So for all negatives, it's an error.
yeah, so here we'll just, so 0 will be 0.
Yeah, and 0,6.
0.67, okay.
0,95.
That's for the positive one.
Yes.
Okay, and then for the negative one,
Is 0 is 0, I guess.
hmm?
I guess 0 is 0.
Mm-hmm.
Yes. And then have 1, which is negative 0.67.
0.67 negative. So the other one would be negative 0.95.
Yes.
Okay. Okay. Do that. And we'll do that. So I'm gonna keep it at 1, negative 1, negative 1, and 1. Maybe not like that. Yeah, I think we'll do it like that. So we'll have 0. Because h of x has 2.2, we might have to go a little bit above 2 on the y-axis. But because the other ones, x values we don't need to go above 1 for them. So for h of x,
That one is 8.8. Or you cutting negative 2? Or you starting from 0?
oh, I'm doing it so that if we just look at these values here,
Looking at the positive values.
these ones here, it's easier to plot the graph.
Okay.
And then for the inverse, we'll just maybe focus on those ones there. So blue for original f of x, green for the positive, and red for the negative. And then y equals x, would be yellow. Okay, so blue, we have at point 1, it maps to 2.2, so a little bit above 2 there. At so it goes like that, and 0, 0, and then we also have at negative 1 somewhere a little bit above, so our curve would do something like this. Fish. Yeah, that's more like it. Okay, so h of x is 11 over 5x squared. Okay, now we do the green graph, right? So at 0 we have 0. At 1 we have 0.67. So for x is 1, y is at about 2/3, so somewhere there we'll have our curve. And for x is 2, it'll go a little bit above there to close to 2. So our curve will do something like that. Then for the negative half of h inverse, we'll also have something similar, where So this would be h inverse of x is negative root 5x over 11. Just want to make the green one. Inverse of x is positive 5x over 11. Over. Then the question is that we've sketched both graphs on the same set of axes. Then part C, we must restrict the domain of h so that the inverse is a function. And how do we do that?
We restrict the x values.
We restrict the x values, that's correct. So if we restrict the x values of h inverse, then we will have h inverse of x is positive 5x over 11, but x must be greater than or equal to 0, and we can also do that for the negative such that x is positive or equal to 0. Alright.
But they said for the h of x. We must restrict for h of x. Not the inverse.
Oh, the domain of h.
So that the inverse is a function.
Oh.
Because the h of x is a function on its own.
Yes.
And then the inverse is not a function. So we must do something to the normal.
The normal function. Okay, so how do we answer that one?
Yeah, we
said restrict x, ne?
Yes, so x
must be positive.
Positive, yeah.
Yeah.
And so this part falls off.
This part, yeah. Falls off. Okay. That makes sense. Makes a lot of sense. I like question 5. It looks like it's fun.
It looks weird.
It looks weird, eh?
The graph looks weird. You know, like that hairpin that like you use for your hair.
The one that has a zigzag on the top and flat at the bottom. Yeah. I've never used those actually. How do they work?
It's just normal hairpin. You just open it and put it into your hair.
Does it clamp your hair together?
Something like that.
What happens if you flex it and then it can't close?
Then that's on you.
It's broken.
You can't use it unless you put it back together, but I doubt it's going to be the same.
Yeah, I guess if you stretch it past its flexibility limit, it might break. Okay, let me quickly go for a comfort break. I'll be back. 5 minutes.
Alright.
question. Alright, so you said this one looks like a hairpin, right?
Yes.
Oh, by the way, when you're racing, have you played a car game before, like Need for Speed? Have you seen where there's a bend like that? And then it's like a very sharp turn over there.
Yeah.
You know what that bend is called? It's called a hairpin bend.
Because it looks like a hairpin.
Yes. Because it looks like a hairpin.
I played Need for Speed without choice.
No, because of your...
supposed to play Need for Speed.
Because you played with your boy cousins.
Yeah.
Yeah, that's what's up. So we have number 5, ne? G of x is y, oh, not y.
Mx plus c.
Is mx plus c plus c. And we have f inverse of x is a square root x for x values that are either 0 or greater than 0. And both graphs pass the point P for Mr. P for -1. All right, and then we're given a sketch. So let's start off with the sketch. Graphs look something like that. So we've got -1, -2, -3, 1, 2, 3, 4, and 5. That's on the x-axis. And on the y-axis, we'll have 1, 2, and here at the bottom we'll also have -1 and -2. That's the point 0, 0. So at 4, -1, we've got where they both intersect. And we must find the values of A, C, and M. Okay. I'll use a blue color for the straight line, G of x. And then we'll use a green color for F inverse. The inverse of the parabola. Some parabola. So the blue line passes 0 and passes the point 4, -1. Something like that. Not so straight, but we're getting there. And the curve, the parabola, also starts at 0, 0, but it curves something like that. Maybe not like that, but maybe, yeah, much better. So this here is f inverse of x is a root x, and this over here is g of x equals mx plus c. Okay, so to start answering the question A, where we find A, C, and M, how do we do it?
Maybe we can start by looking for C.
For C, okay. How would we find C?
I mean, C is the y-intercept.
Yes.
So C would be -1.
Would it be -1?
Maybe.
Let's give it a go and would start with M.
Okay, the gradient.
The gradient, yeah. Because that way, because if I start with the gradient, then if I know the change in y over change in x, I've pretty much gotten from y equals mx plus c, I've gotten this part. Then I can substitute these two into there and I'll get what c is. So I can say y2 is -1 and y1 is 0, and x2 would be 4 and x1 would be 0. So my gradient would be -1/4. Then I have y equals -1/4 x plus c. Then I can substitute p is 4 -1 into y, such that -1 is -1/4 x, not x, into 4 plus c, which then gives me -1 equals -1 plus c, therefore c is 0. But it's also easy enough to read off that c is 0 because our graph intercepts the intercepts the y-axis at the point 0, 0. So we have an x and y intercept of 0. So we found c and m. Now we're left with a. How are we going to find a?
Substituting p.
We can substitute p into that function.
Yeah.
Okay, so if we have y equals a root x, then -1 equals a times the square root of 4. -1 is 2a, therefore a is -1/2. Okay. Then we must give, okay, I'll just do this so that's neater. So we must find the domain and range for f inverse f inverse. So what's the domain for f inverse? Sorry.
X is an element of positive, x is greater than 0 or equal to 0, and
Okay.
x is an element of real numbers.
Alright, x is an element of real numbers. Perfect. Then what's the range of the inverse function of x?
Y is less than or equal to 0, and y is an element of real numbers.
Hundreds. And then for g?
G of x is an element of real numbers.
And -1/4x. So the domain set of x values such that x is just an element of real numbers, really. And what about the range?
And it's also an element of real numbers.
Y is also
An
an element of real numbers. Yay. Okay. Here's another question. For which values of x is g of x smaller or less than f of x? F of x, not f inverse of x.
So must divide it back to f of x.
Yeah. So if
Maths is quite is unnecessary sometimes. Why don't they just say f of x?
I know,
Inverse.
right? Our equation is negative half square root of x, right? That's for f inverse. Then
it's so extra.
F of x would be, so we first swap, right? So we'll have y equals negative half x. X is negative half y. Make y subject. So we square. So that x squared is 1 over 4y, and y is 4x squared, which is f of x. Okay. So maybe we can plot this. For negative 1 and the other one. So our graphs initially look like that. So for 4x squared, we will have something that looks like this. But at the point x equals 4.
What is your graph?
That's how.
It looks weird.
It looks very weird, né?
Especially the side.
Okay, let me start it afresh.
Can we have arrows as well?
And I guess different colors as well.
Yeah.
Different colors. Initially, blue was a straight line. So let me just. Okay. 1, 2. It's gonna be too small.
2, 4. 2, 4, 6.
Yeah, I should make the scale bigger. Okay. 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. 1, 2, 3, and 4. That's y, that's x, that's 0, negative 1, negative 2. Okay. So blue graph was a straight line and it passed the point 4, negative 1, and 0. And it went something like that. No, it's not straight enough. That's straight enough. Yeah. And then the other one was green. And it curved a little something like that. Does that look better? Okay.
It makes sense now.
It does make sense. Okay. Then for 4x squared and x is negative 2, 16, and x is 1, we get 4. So that means I'll make it red. Let me make it red. But first, erase these green dotted lines. Right. So at x is negative 1, y is 4, and x is 0, y is 4. Okay. So curve will behave like this. All right. I'm just waiting for your nod of approval, because if it doesn't look right, you're gonna.
It must make sense for everyone.
Okay, fair enough. I can respect that. So, okay, for which values of g of x rather, is this is f of x.
G of x is a straight line.
I wanna f of x g of x also.
No.
No. What's the other one? F inverse of x. Okay, cool. So yeah, we must determine for which values of x is g of x less than f of x. Is there a point where g of x is less than f of x? We can start asking that question.
You know, this question is the question I always skipped.
Really?
I always get this question because I always got it wrong.
Okay.
So it was just a matter of like, I'm just going to get it wrong either way and just continue.
Okay. Well, now we have a chance to talk about it.
Yeah.
So, if we're looking at where g of x is smaller than f of x, where would that be on?
Smaller in what terms?
Like less than, like
the value.
Like okay, let's think about it this way. If x is positive, right? If x is positive, so in other words, we're moving in the positive x direction. Are there any values of the straight line that might be equal to or greater than the values in the parabola?
Are you talking about in terms of the x?
Yeah, we're looking about.
I don't understand this question. I don't understand this question because.
Let's think about it this way. On our red curve, that parabola there, right? For the point x is, let's look at the point x is negative 1. Let's look at this point here. X is negative 1. Make that yellow. So we're going to look at this point here. X is negative 1. So at x equals negative 1, when we substitute negative 1 into the straight line, we get a value that gives us a positive y. So some value of y between negative 1 and 1, right? When we substitute the same negative 1 into the curve, we get y equals 4.
Right? Which is greater.
Which is greater. So
basically what we're looking for is that when we're substituting x into the value, into the equation, which y value is greater.
Which y value gives us that the straight line is less than the parabola. The value of the straight line is less than the value of the parabola.
So basically we're comparing the y-axis.
We're comparing the y values, yes.
Oh.
So for the straight line, which is g of x, remember we must find where on x is g of x less than f of x. So we've plotted f of x. We want where g of x, the straight line, is going to be less than f of x.
All the points are going to be less than f of x, of g of x.
I wouldn't say all. Let's first write the equations. Majority of them, but we want to know exactly from where do we start having g of x less than f of x. So g of x, our straight line, is negative a quarter x. Remember that? And our f of x we found as that, right? F of x is 4x squared. Okay. I would say let's start first with where is it that g of x equals f of x. So at negative a quarter equals x equals 4x squared. That's where they intersect, right? And where they intersect, if we divide, let's say we left with negative a quarter equals 4x. X equals negative 1 over 8. Okay, so where x is negative 1 over 8, they intersect, right? But what happens where x is negative? So what could it be that for any values of x greater than or equal to negative 1
over
8, then g of x will always be less than f of x. Because anything greater, let's say positive 1 over 8, for h of x, for f of x, it will give us positive 1 over 16. Let's substitute. Let's work with x is positive 1 over 8, and then we substitute that into g of x. So negative a quarter times positive 1 over 8 will give us 1 over
negative 1 over 32.
And then let's substitute the same positive 1 over 8 into f of x.
1 over 16.
1 over 16. So which one's greater?
1 over 16.
1 over 16. So that means where x is positive, and greater than negative 1 over 8, then this is true. G of x is less than 1 over 8. Because if we are at, let's start at negative 1 over 8 and substitute that into here.
I'm going to start with
Negative 1 over 8.
I'm going to start with f of x.
Or g of x.
No, right now I'm starting with f of x because it's the one I'm
Okay.
later. It's 1 over 16.
Okay. And then for g of x?
1 over 32.
1 over 32. Which one's greater?
1 over 1 over 16.
1 over 16. So, okay, so it's not really equal. Maybe I'm making a mistake. Okay, because what I want to explain, or what I want to convey is, there's a certain point, right, where the two graphs might be equal. That's where they intersect.
Isn't it 0.0 to 0?
0.0 to 0, yes. Then, at a certain point, Okay, what we just did now at x equals 1/8, we found that this one is greater than this one, right? And when we're working with -1/8,
no, these two are the same. When 1/8, positive 1/8, it gave
Okay.
us f of x is greater than g of x.
Okay, so at positive 1/8, we found that f is greater than g.
Even at negative 1/8.
F is still greater than g. Okay. So what? All values of x?
Like I said in the beginning.
Yeah. But okay, like you said in the beginning. And I guess then that would mean it just doesn't look like that, because it kind of looks like at some point the x values are gonna be the same, or some would be.
The x values and the y values are going to be the same at points raised to 0.
Yeah.
You know what I'm saying? And that graph is moving up, it's increasing
The
function.
parabola is an increasing function.
Yes, and then g of x is a decreasing function, so they won't meet at any point all the time.
Okay.
Except for
I like that. I like that. I like that. Okay, and then
so what is our conclusion?
our conclusion is that for all values of x,
for all values of x,
g is less than f of x.
Okay.
Yeah, for all values of x, g is less than f of x.
Okay. Because we checked with negative 1/8, it was still positive.
And
with
with
1/8
the other
was
one.
still positive.
Yes.
Let's check with zero. It's still gonna give us 0
Yeah.
for both of them. That's where they're equal. Okay.
I wanted to see something. 2-4, exercise 2-4, 2-4, 2-4. Number 6. Is number 6?
No, I was just saying 2 for 6.
Oh, it's number 5. Huh.
Number 5 what?
Values of x, it says x is larger than 4. It says x is larger than 4, unless this meant the inverse. Okay, for which values of x is g less than. Okay, let's say the question was about the inverse. If it were about the inverse, for which values of x would the straight line be less than, and it says there x is greater than 4, so okay, so the answer in the learning guide is about, instead of it being f of x, it's about being f inverse, because it says the answer is x is greater than 4, meaning for any value of x, so let's say x equals 5, then the curve of f inverse has a greater value than the straight line.
I think they made a mistake, because it only makes sense if it was f of inverse of
instead
f.
of f. Yeah. That makes a lot of sense. And then to determine f, let's see, 4, 7. To determine, okay, f we did get right. It is 4x squared. And yeah, I guess. Let's go back. Alright. Then we have to also find the coordinates of the points of intersection of G and f of, is it f of x or just f?
You see these people.
Okay.
That was writing this book. He's a snack on this. He's not focusing.
I mean, it's fine with the typos in the book.
I think right now they want f of x because we solved for f.
We found f of x,
Yeah.
yeah.
I think it would be fair to use
F, okay. Cool. I just want to rewrite the answer to this one and also have on our voice that, okay, I want to remove this part, it's no longer necessary. So I just want to say f inverse is negative a half root x, right? And x is greater than or equal to 0. So at x is greater than 4, then g of x is less than f inverse of x. Right. Then the last one is points of intersection. For G and F. So for G and F, remember we drew F just here, and F of x only intersects at the point 0, 0. So that is valid. But now if we were to find a different set of points where I guess the straight line intersects the curve or curves, where would that be?
That's if we shift the graph downwards.
Okay, we don't have to shift the graph down. I don't think that's necessary. But
no, I'm saying, but explain.
Because I mean, we're not doing anything about horizontal or vertical shifting of graphs at this stage, so maybe that we shouldn't think about yet. Because other points where I see the straight line intersecting the curve are where the straight line intersects f inverse, which is at the point that we're given as p.
But aren't they talking about f?
Oh, the curve f. I don't see anywhere else where they could intersect.
Determine the coordinates of point.
Or points of intersection of f and g. Yeah, I think 0, 0 is the one. Other than that, I don't see any other.
I also don't see any other point.
Yeah, so I'll just note that.
Let's check the answer.
It gave other vibes, eh? 4, 5, 7. It gave, check this. It gave negative 1 over 16 is to negative 1 over 64.
No, it's negative 1 over 16 is to 1 over 64.
Yeah.
But how did they come to a point where that's the answer?
We can explore how that works by, I want to see something.
Could our graph be wrong?
No, I think it's right. Negative 1 over 16 would be there, and 1 over 64.
It's not come as 06, it's just after 0.
That's on the y-axis, right? That's the positive one.
It's x.
That's x. I think this needs more investigation. Because number one, the graph that we originally have only shows 2 points where they intersect, where the straight line and f inverse intersect. Now we had to draw f of x, unless we substitute, rather we equate. Yeah, let's do this.
Equate what, g of x
And f of x, yeah. So let's do that.
Didn't you do that and it gave you negative 1/8?
The math was not right.
Okay.
The math was not right. I just remembered. So g of x is negative 1/4x, right?
Mm-hmm.
And f of x is 4x squared.
Mm.
So you need to find where 1/4x equals 4x squared.
Mm.
0 is 4x squared plus 1/4x.
Mm.
That's why the math was wrong. X into 4x plus 1/4. Therefore, x is 0, or 4x equals negative 1/4, and x is negative 1/16. That's how they've got the first coordinate.
Mm-hmm.
Then the second coordinate, we would substitute this into either that or that. And substituting into g of x, we get g of negative 1/16 is negative 1/4 times negative 1/16, and that gives us positive 1/64.
Okay. Kind of makes sense.
Totally does.
It
Totally
does.
does, yeah, totally does. So even if the graph looks terrible, we can still accurately determine the intercepts because of how we do the math. Alright. Sun's burning.
They're burning food.
That sounds like felt. Sounds like bush. Okay, let's do worked example 9. On page 67. And it's about finding average gradient with the same types of problems, right? So we're given h of x equals 2x squared, and x is positive, equal to or greater than 0. We must find the inverse such that if y equals 2x squared, then inverse would be x equals 2y squared, making y subject of formula. X over 2 equals y squared. Y is positive or negative root x over 2, and x is positive or greater than 0. Right? That's the first step. Therefore, h inverse would be x over 2. Just keep that there for now. We must find, the second part is to find the point where do h of x and h inverse of x intersect. So that's where h of x equals h inverse of x. Okay. So 2x squared will equal root x over 2. If we square both sides, we get 4x to the power 4 equals x over 2. And 8x to the 4 equals x. 8x to the power 4 minus x equals 0. Taking out x, we get 8x cubed minus 1 equals 0. So it's at x equals 0 or 8x cubed minus 1 equals 0. 8x cubed would equal 1 x cubed is 1 over 8 and x is a half. Where x is a half, how much is y? A half squared is a quarter times 2 y also equals a half. Okay, so these curves intersect at the point 0, and the point a half. So I guess in the sketch they show how they intersect, and it looks something like, just make a quick illustration.
Insect antennas. Looks like antennas.
It looks like antenna, yeah.
Of like a bug.
So the first curve looks like that, and the second curve looks like that. Look like antennas of a bug. Isn't God in everything? Isn't God in everything, even in maths?
He is.
Yx, okay. So something like this, maybe that's 1 there, that's 1 there, that's 0. That would be half, that would be half. So our curves look something like that. That would be h of x, and that would be h inverse of x. Alright. Okay. So we've determined the inverse of the function, we've determined the points of intersection, we've sketched the graphs, and on the same set of axes. Then we're now using the sketch to determine if h and h inverse are increasing or decreasing functions. Okay. So to find if our graphs are increasing or decreasing functions, just create space there. Yeah. Both, okay, vertical line test. They pass, right?
I guess they're two different functions.
Yeah. So they pass vertical line test. That's great. They're both functions. So h and h inverse are both functions because they pass vertical line test. Ne? Right. Then let me straighten my back a bit. Yeah. Then as h increases, or rather for h, as x increases, y also increases. So let's look at h. X increasing implies y also increasing. Therefore, h is an increasing. And for the inverse, as x increases, y also increases. Therefore, h inverse is increasing. Then the average gradient would be, okay, then the average gradient of h between the 2 points of intersection. Okay. And then lastly, average gradient between 2 points of intersection. So we have to find the average slope between the points 0, 0 and I guess a half, half, which is the 2 points of intersection. And that would be m average equals change in y over change in x, which is yb minus ya over xb minus xa. That's a half minus 0 over half minus 0, and that gives us 1. And this is also for the inverse function. Also for the inverse function. Okay, we can stop here for now, né?
Okay.
Yeah. We can stop here.